A well-formed formula is said to be in conjunctive normal form when it has the following form: a sub 1 and a sub 2 and a sub n, where each one of these, a sub 1, a sub 2, a sub n, is an elementary disjunction, and where you at least have one formula. So let's start by looking at a case where n is equal to 1. So in other words, we have a formula and we're asking ourselves, is this formula in conjunctive normal form? And the formula does not necessarily need to be a conjunction here. So it doesn't need to have the form a sub 1 and a sub 2. We're just asking for a given formula, whatever it might be. Can this formula be in conjunctive normal form? The answer for that is yes, provided that formula is an elementary disjunction. So a sub 1 can be in conjunctive normal form provided it is an elementary disjunction. What this means is that that formula either needs to be a literal well-formed formula or it needs to be a disjunction of literals. Let me give you examples of each. So in the case of literals, if we had a formula like P, not Q, or R, well, then these formulas would be in disjunctive normal form because they are literal well-formed formulas. And since they're literal well-formed formulas, they're elementary disjunctions because all literals are elementary disjunctions. And since it is an elementary disjunction and it has the form A1, it is a single proposition or formula, then it is in conjunctive normal form. The other case would be if you have a formula, it's an elementary disjunction, and that elementary disjunction is a disjunction of literals. So let's say you had P or Q. This is a disjunction of literals. So you have P here and Q. Each one is a literal and it's a disjunction of them. And so this would be an elementary disjunction. And so this disjunction is actually in conjunctive normal form. Another example would be not P or S or not T. This formula is a disjunction of literals, and so it's an elementary disjunction, and so it is a formula in conjunctive normal form. So if we're looking at a single formula and asking ourselves, is this formula in conjunctive normal form? The answer would be yes, provided you are looking at a case of a literal well-formed formula or a disjunction of literals. Now, what about the case where n is not equal to 1? So we're not looking at a single formula, but n is greater than 1. So we're looking at a formula that has the form, let's say, a sub 1 and a sub 2 and, all the way up to a sub n. So we're actually looking at a conjunction and asking ourselves, is this formula in conjunctive normal form? Well, the answer to this is yes, provided we have a conjunction of elementary disjunctions. So if we had a conjunction where we have elementary disjunction 1 and elementary disjunction 2 and all the way up to elementary disjunction n, so provided we have a conjunction where each one of the conjuncts, each one of these subformula here are elementary disjunctions, then it would be in conjunctive normal form. Again, each one of those elementary disjunctions is either a literal, so it's a formula like P or not P, or it is a disjunction of literals. Let's take a look at some examples. Let's say we had P and Q. When we look at this formula, one thing that we see is, look, it is a conjunction and it has the form of a sub 1 and a sub 2. Now, is it the case that P, which is our a sub 1 here, and Q, which is our a sub 2 here, is it the case that P and Q are elementary disjunctions? That is, are they literals or are they disjunctions of literals? The answer here would be yes, they are elementary disjunctions. And so we have a conjunction of elementary disjunctions. And so this formula would be in conjunctive normal form. Let's look at another example. Let's say we had not P and not Q and R. So our question again is this in conjunctive normal form? First thing to note is that our formula has the following structure: a sub 1 and a sub 2 and a sub 3. So our question becomes, is each one of the conjuncts in this formula an elementary disjunction? That is it a literal or a disjunction of literals? And so if we look, not P is a literal, not Q is a literal, R is a literal. And so each one of these conjuncts is an elementary disjunction. And so this formula would be in conjunctive normal form. So let's say we have the formula not P or Q. So we have this disjunction here, and then we had and S or T. Now, one way of going about this is to ask ourselves two different questions. The first question would be, if we treat this whole thing as a single formula, is this formula an elementary disjunction? So is this whole thing an elementary disjunction? The answer to that is no, it is not. And so from that fact, we cannot conclude that this is in conjunctive normal form. If it were an elementary disjunction, that is, if it were a disjunction of literals or it were just a literal, then we could conclude it is in conjunctive normal form. The other question we can ask ourselves is, well, let's take a look at the structure of this formula. And one thing to note is we see that it is a conjunction. And it's a conjunction of two different formulas. So we can look at it as a sub 1, which is the left conjunct here, and a sub 2, which is the right conjunct there. Now that we see that this is a conjunction, is it a conjunction of elementary disjunctions? That is, do we have ED1 and ED2? That is this formula right here an elementary disjunction? And is this conjunction here an elementary disjunction? If this conjunction is composed of two elementary disjunctions, then it would be in conjunctive normal form. So we see that yes, not P or Q is a disjunction of literals, and so it is an elementary disjunction. And then S or T is also a disjunction of literals, so it too is an elementary disjunction. So we have a conjunction that is composed of two elementary disjunctions. And so yes, this is a conjunction of elementary disjunctions, and so it also is in conjunctive normal form. Let's look at some examples of formulas that are not in conjunctive normal form. So let's take a look at the formula P right arrow Q. Now we could of course ask ourselves the two questions, which would be, first, is this an elementary disjunction? The answer to that would be no, it is not an elementary disjunction because it's not a literal, and then also it is not a disjunction of literals. The second question would be, well, is this formula a conjunction of elementary disjunctions? The answer to that is also no. This formula is not a conjunction at all. Notice that there is the sign for conditionality right there. And so this is a conditional rather than a conjunction. And so from this fact, we can conclude that this formula is not in conjunctive normal form. Now let's take a look at this formula, P and Q or R. Again, one way of approaching whether or not this formula is in conjunctive normal form is to first ask ourselves, is it an elementary disjunction? That is, if we just treat it like a single formula, is it a literal or a disjunction of literals? Now, the right disjunct here is a literal. This R here is a literal, and it is a disjunction, but notice that it is not a disjunction of literals because we have this P and Q here. It's a disjunction of R and a conjunction. So the answer to this would be no. And so this formula would not be an elementary disjunction. Again, the second question we can ask is this formula a conjunction of elementary disjunctions? If it is, then we can say it is in conjunctive normal form. However, when we look at this formula, we see that it is not a conjunction. In fact, it is a disjunction here. And so we can say also that this is not a conjunction of elementary disjunctions. And since we can answer no to both of those questions, this formula is also not in conjunctive normal form. So my challenge to you is to look through these 8 formulas right here and determine which of the 8 formulas are in conjunctive normal form. I'd love to see your answers in the comments below, or if you have any insights about how best you think about or understand conjunctive normal form or normal forms in general, I would love to read those as well.